All right, today we're going to unlock one of the most useful tricks in all of algebra, tackling logarithms without a calculator. And look, this isn't just some party trick. It's about really building a deeper number sense. So you see a problem like this on a test. What's your first instinct? If you're like most people, you immediately reach for the calculator, right? Well, what if I told you there's a faster, way more intuitive way to get the answer? It's all about understanding what the question is really asking. Okay, here's our game plan. We'll look at the problem, I'll show you the secret strategy, we'll run through some examples, and then we'll cover common traps, why this whole thing matters, and how you can make this your new superpower. So the problem isn't really the logarithm itself. It's that gut reaction, that reflex to think we need a machine to solve it. But honestly, it's just a simple question in disguise. And here it is. This is the secret strategy. A logarithm isn't about division or some crazy complex operation. It's just asking one simple question. What exponent turns the little number, the base, into the big number? And whatever that exponent is, well, that's your answer. Seriously, it's just 2 steps. Step 1, you rewrite the main number, the argument, as the base raised to some power. Step 2, that exponent you just found, that's it. That's the whole answer. Now, to make this work, you just got to be a little familiar with some common powers. Think of this table as your mental cheat sheet. Just knowing that, 32 is a power of 2, or that 125 is a power of 5, that is the key that unlocks this whole mental math technique. Okay, theory is great and all, but let's actually see how this plays out in the real world. We're going to walk through 3 examples, starting with a basic one and then getting a little trickier. So let's go back to that original problem, log base 2 of 32. The base is 2, the argument is 32. Our only job here is to find the exponent that connects those two. And this right here is the key step. We just ask ourselves, 2 to what power equals 32? Let's count it out on our fingers if we have to. 2 times 2 is 4, then 8, 16, 32. Yep, that's 5 times. So 32 is just another way of saying 2 to the 5th power. And since we rewrote 32 as 2 to the power of 5, the answer is just that exponent. It's 5. See? No calculator needed at all. All right, ready for something a little different? Let's try one with a fraction. Log base 5 of 1 over 125. Now don't let that fraction scare you. The strategy is exactly the same. Okay, first things first. We know that 125 is 5 to the 3rd power, right? 5 times 5 is 25. Times 5 is 125. But since it's in the denominator, it's times 1 over 125. That tells us we're dealing with a negative exponent. So 1 over 125 is just the same thing as 5 to the power of negative 3. And you guessed it, just like before, the exponent is the answer. So log base 5 of 1 over 125 is simply negative 3. The same 2 steps, they work perfectly every time. Okay, time to level up. Here's our advanced example. Log base 9 of 3. Now this one might look a little weird, a little backward, because the argument, 3, is smaller than the base, 9. So what does that mean? Well, it means we're dealing with roots. So the question is, how do we write 3 as a power of 9? Well, think about it. 3 is the square root of 9, right? And in the language of exponents, a square root is just the power of 1/2. So 3 is just another way of writing 9 to the power of 1/2. So the exponent is 1/2, which means the answer is 1/2. And this brings up a really crucial point. The solution to a logarithm can absolutely be a fraction. It doesn't always have to be a whole number. All right, now that you've got the strategy down, let's make sure it really sticks by looking at 2 of the most common mistakes people make. If you can avoid these 2 traps, you've pretty much mastered this whole thing. The biggest trap by far is thinking that log base 2 of 8 means you just do 8 divided by 2. No, the answer is not 4. You have to remember to think in powers. Ask yourself, 2 to what power gets me to 8? Well, 2 times 2 is 4, times 2 is 8, so the answer is 3, because 2 cubed is 8. And the second big trap is assuming the answer always has to be some nice, clean, whole number. We just saw that's not true at all. Remember our last example? Log base 4 of 2 is 1/2, because the square root of 4, or 4 to the 1/2 power, is 2. So, you might be thinking, okay, cool trick, but why does this actually matter beyond passing a math test? Well, because this isn't just a trick. It's a fundamental concept for measuring efficiency, especially in fields like computer science. I want you to imagine you're a computer program, and your job is to find one specific item in a sorted list of, say, 1,024 different things. That sounds like it could take a while, doesn't it? But by using a method called binary search, which is totally based on logarithms, the computer only needs to make at most 10 comparisons to find what it's looking for. That's because log base 2 of 1,024 is 10. I mean, that is an absolutely incredible leap in efficiency, and it's all powered by the simple logic of logarithms. So let's recap. The big takeaway here is this. Evaluating a logarithm is just about finding a missing exponent. That's it. And when you reframe the problem that way, you can usually solve it in your head way faster than you could ever type it into a calculator. And that kind of leaves us with a final thought. This shortcut for logs, it wasn't really a shortcut at all, was it? It was about understanding what the numbers truly represent. So, my question to you is this. What other math rules or tricks out there might suddenly become obvious if we just try looking at them from a slightly different angle?